Okay, welcome to another past paper session. Today's paper is again paper 1 from November 23. This is third variant. Let's start solving quickly. Let's see what the first question is. This is a curve which such that the gradient is given by this. It is given that the curve passes to the point that. Find the equation of the curve. So this looks like a simple integration question. So I'm going to write my differential first and then put an integration sign on both sides and say that this becomes x squared over 2 minus 3x power minus half plus 1 divided by half plus c. Now to figure out c, I will use that point 4 comma 1 and say that this is 4 square and 4 power half over half plus c. Okay, so that should give me 8. That should give me 2, 2, 4, 12 plus c. So c comes out as 5. So my equation is y equals to x squared over 2. And then 3 divided by half gives me 6. X power half minus 6x power half plus 5. Let's check if that is the correct answer. Okay, that is the correct answer. Let's move on to the next question and see what that is. It says a circle with equation x minus 3 whole square plus y minus 5 whole square equals to 40. So the center is 3 comma 5, intersects the y-axis of the points a and b. Find the coordinates of a and b, expressing your answers in terms of surds. So I'm asking you to express in terms of roots. So y coordinates of a and b, it intersects the y-axis. So I can say that x is 0. I'm trying to find the y-intercepts. Okay, now there are various ways to do this question. I will do this with without opening up my expression, and the reason is because I actually want sets at the end. So 40 minus 9, that gives me y minus 5 whole square equals to 31. When I take a root on both sides, I get y minus 5 equals to plus root 31 and y minus 5 equals to minus root 31. So y equals to 5 plus root 31, y equals to 5 minus root 31. Okay, those are a and b. Okay, remember that x coordinates are 0. Okay, find the equation of the circle which has AB as its diameter. So 0 comma 5 plus root 31, and I kept the second one as negatives. So when it has AB as the diameter, remember that the center of the circle will lie on the center of the diameter, and you can find that by calculating the midpoint. Okay, so the midpoint is going to be 0 plus 0 divided by 2. Uh, yeah, 0 plus 0 divided by 2, and 5 plus root 31 plus 5 minus root 31 divided by 2. So that gives me 0 comma 5. So I'm going to say that this is x minus 0 whole square plus y minus 5 whole square. I still need the radius, so I'm going to calculate the distance of AB and then divide by 2. So 5 minus root 31 minus 5 minus root 31, y2 minus y1 whole square plus x2 minus x1 whole square. That gives me 5 and 5 cancel out. So root 31 into root 31, and that's squared. So that's minus 2 root 31 squared. The square and root will cancel out. But it's going to get squared. Let's not rush through this. So that gives me 4 into 31. Okay, so I am getting 2 root 31 out of this. That is my diameter. Radius is going to be half of that, so root 31. So this is radius squared here. So I'm getting x squared plus y minus 5 squared equals to 31. Okay, moving on to the next question now. It says show that the equation this can be expressed in the form a cos square plus b cos theta plus c. So I want everything in terms of cos. So I'm going to say that sine theta over cos theta plus 1 equals to 0. 5 cos theta minus sine square theta over cos theta plus 1. 5 cos square theta minus sine square theta plus cos theta equals to 0. Okay, so 5 cos square theta minus 1 minus sine 1 minus cos square theta. This cross multiplies and becomes 0. So I get 5 cos square theta plus cos theta, sorry, 6 square theta plus cos theta minus 1 equals to 0. Let's check if that is the right answer. Yes, that is indeed the right answer for 3 marks. It says hence solve the equation, so I solve this one only. I will first apply the quadratic formula and tell you that there are two roots. Okay, I will do the quadratic now on my calculator. 6 1 minus 1 gives me 1/3 and minus half. So cos theta is 1/3 and cos theta is minus half. So quadrant 1 and quadrant 4. And I have to give that in radians, quadrant 2 and quadrant 3. So alpha equals to cos inverse of 1/3. Cos inverse of 1/3 in radians. 1.23. Cos inverse of half. 5/3. Okay, so alpha equals to pi/3. Quadrant 1 is 1.23 and quadrant 4 should be 2 pi minus 1.23. Quadrant 2 is going to be pi minus pi/3, 2 pi/3. Quadrant 3 is going to be pi plus pi/3, which is 4 pi/3. Let's see if we have all the correct answers. Okay, I haven't calculated this. Let's quickly calculate this. 2 pi minus 1.23. That's 5.05. Okay. Yes, those are the correct answers. Let's move on to the next question now. I don't know, there was a lag in the middle. I don't know why that was. Expand the following in ascending powers of x up to and including the term in x squared. Um, Hold on. Okay. So expand up to and including the term in x squared. So 5c0, 1 power 5 minus 0, 2x power 0, 5c1, 5 minus 1, 2x power 1, 5c2, 1, 5 minus 2 is 2x power 2. So I get 1, I get 5 into 2, 10x, and 5c2 is 10 again. 10 into 4 is 40x squared. So I get 1 plus 10x plus 40x squared. Then 1 minus ax power 6, where a is a constant. So 6c1 or 6c0, 1 power 6 minus 0 minus ax power 0. So that gives me 1, 6c1, 1 power 6 minus 1 minus ax power 1. So minus 6ax and 6c2. 1 power 6 minus 2 minus ax power 2. So that's 15 a square x squared. In the expansion of 1 plus 2x power 5 and 1 minus ax power 6, the coefficient of x square is minus 5. So 1 plus 10x plus 40x squared. Let's first check our expansions if they were correct. Yes, 1 plus 10x plus 40x squared. That was correct. And 1 minus 6ax plus 15ax squared x squared is correct. It's saying that the coefficient of x squared is minus 5, so it's approximately equals to minus 5x squared, just the terms in x squared. How do you obtain the terms in x squared? You do the selective multiplication that we've learned. We do 15a squared x squared. We do, that's 1 into 15a squared x squared plus 10x into minus 6ax. That gives me another x squared, and this gives me another x squared. So 40x squared into 1 should be approximately equals to minus 5x squared. Okay, I'm putting approximately equals to because I've ignored the other terms. Okay, 15a squared x squared minus 60ax squared plus 40x squared equals to minus 5x squared. Okay, then I see x squared in all the terms. Can I just cancel that out? I'm taking a common and cancelling it out because x squared is irrelevant. I'm trying to find the values of a. 15a squared minus 60a, and then I have 45 equals to 0. Okay, let's see if I can solve that on my calculator. I'm going to do minus b plus minus root of b squared minus 4ac over 2a. 15 minus 60, 45. 3 and 1. Let's see if there was some limitation. I don't think there's any limitation. You can have both values. So a is 3 and a is 1. Let's check if those are the correct answers for us. Okay, looking at the next question now, it says the first, second, and third terms of a geometric progression are 2p plus 6, 5p, and this, and the possible values of the constant p. So it's a geometric progression. I could do AR and AR squared and so on, but I can also tell you that the common ratio between these two would be the same as the common ratio between these two. So how do you calculate the common ratio? You do term 2 minus term 2 divided by term 1. So that's 5p over 2p plus 6. That should be equals to what? That should be equals to 8p plus 2 divided by 5p. Okay, cross multiplying this gives me 25p squared equals to 8p plus 2 times 2p plus 6. Okay, and then I have 25p squared. I have 16p squared plus 48p. I'm multiplying 8p by the bracket, and then plus 4p plus 12. So 25p square minus 16p square minus 52p minus 12 equals to 0. So that's 9p squared minus 52p minus 12 equals to 0. I'm going to use my quadratic formula. Okay, putting that on my calculator again. 9 minus 52 minus 12. So p is 6 and p is minus 2 over 9. Okay, possible values. So those are the two possible values. One of the values of p found in is a negative fraction. Yes, we know that. Use this value of p to find the sum to infinity of the progression. So the sum to infinity is a over 1 minus r. Okay, how do I find the sum to infinity? I'm going to say that a is basically 2p plus 6. So 2 times minus 2 over 9 plus 6. And what is r? R is term 2 divided by term 1, so 5p divided by 2p plus 6, so 5 times minus 2 over 9 divided by 2 times minus 2 over 9 plus 6. I'm going to do that step by step. Don't rush through this. First calculate your r or the numerator first, and then see how your question is solving, and get me a final answer. 2 times minus 2 over 9 plus 6, so my denominator is coming out as 50 over 9. My R is coming out as 1 minus, let's say what I'm getting, 5 into minus 2 over 9 answer divided by 2 times minus 2 over 9 plus 6. I'm getting this as minus 1 over 5. So then I type in into my calculator 50 divided by 9 over 1 plus 1/5. I am getting a total answer of 125 over 27. Okay, so simple answer, nothing complicated about that, it's just that you have to get the numbers correct. Okay, a line has equation this and a curve has equation that, where c is a constant, the line is a tangent to the curve. So whenever I'm talking about two things, it's b square minus 4ac equals to 0. Find the possible values of c and the corresponding values of that. So 6x minus c equals to cx squared. I'm going to first solve simultaneously and then see what I get. So cx squared minus 4x plus c minus 3. A is c, b is minus 4, c is c minus 3. B squared minus 4ac is equals to 0. So I get 4c squared minus 12c plus 16 equals to 0. Okay. Okay, solving this, minus 12 plus minus b squared minus 4ac over 2a. That gives me, let's see on my calculator, okay, let me check if I have the correct. Okay, this should be minus 16. Yep, 4 and minus 1. So c equals to 4 and c equals to minus 1. Those are two answers right now. Let's see which one I have to consider. Just find the possible values of c, where c is a constant. So I'm going to consider both values and then I have to find the corresponding coordinates of p, where p is the tangent to the point. So I'm going to say that the two curves meet at p. So the first curve is 6x minus 4 in this case, and the second curve is 4x squared plus 2x minus 3. I have inserted into both. I'm going to solve this simultaneously. You could essentially pick up from here and also insert the values of c and find out, and I'm going to do that in the next minus 1. Okay, so you could insert the values of c and quickly solve. So 4x squared minus 4x plus 1. So x comes out as 1 over 4, I think. I'm going to put that on my calculator again and solve. Uh, so x comes out as half, I think. Yeah, x comes out as half. 4 minus 4 and 1. So x is half and y is 6 times half minus 4, which is minus 1. So p could be half comma minus 1. And then I have y equals to, let's solve from here. 0 equals to minus 1x squared minus 4 times x minus 1 minus 3. So minus x squared minus 4x minus 4 equals to 0. So x squared plus 4x plus 4. Minus 16. I don't know if I'm getting the correct answer. Oh, that shouldn't be 6. That should be minus something. 6x minus. Okay, so y should be, it's 6x minus c, so 6 times minus 2 times minus 1. So that's minus 12 plus 1 minus 11, so minus 2 comma minus 11. Okay, that is the correct answer. Let's move on to question number 7. It says the function f is defined by f of x equals to 1 plus 3 over x minus 2 for x is greater than 2. State the range of f. Notice that this is going towards infinity. This is a reciprocal function. Reciprocal functions tend to look like this. Okay, they are downward sloping and they usually have an asymptote at some point. Either they are approaching zero normally. So if I were to draw this curve for just 3 over x minus 2, the asymptote would be at 0. But here, since I see a plus 1, the asymptote seems to have moved. But if you can't figure that out, the simple idea is that you take a large number instead of x on your calculator. Let's try to do that on a calculator and see if we find something that's useful to us. Okay, so what I'm going to do is on my calculator, I'm going to say that 1 plus 3 over, and I'm going to put a large value for x, 99999, and then I put minus 2. So x is stretching to the right. Okay, so it's saying that it approximately reaches 1. So whatever value of x I take, it does not cross 1. What happens at 2, when I put in 2, the denominator becomes 0. The calculator is obviously going to give me an error, but I know that an error on the calculator means infinity. So the range of f is basically less than infinity but greater than 1. The lowest possible value that I could find for x was 1. A very large value of x gave me 1. So y is greater than 1 but less than infinity. You can ignore the less than infinity if you want. You can just write y is greater than 1. Then it says obtain an expression for f inverse of x. So I'm going to say that f inverse of x is simply making x the subject. Okay. So y minus 1 equals to 3 over x minus 2. X minus 2 equals to 3 over y minus 1. I've reciprocated and shuffled it around. And now I'm going to say 3 over y minus 1 plus 2. So f inverse of x gives me 3 over x minus 1 plus 2. What is the domain? The domain is the range of the original function. What was the range of the original function? From 1 to infinity. You can ignore the infinity if you want. It's not necessary. Okay. The function g is defined by g of x equals to 2x minus 2 for x is greater than 0. Obtain an unsimplified simplified expression for gf of x. So f of x is 1 plus 3 over x minus 2 simplified expression. Okay, so gf of x is basically 2 times f of x minus 2. What is 2 times f of x? It's 1 plus 3 over x minus 2. So 2 plus 6 over x minus 2 minus 2, that's 6 over x minus 2. So that's gf of x. Okay, let's look at question number 8. This looks like a question on transformation of functions. Let's see what it says. It says y equals to sine ax plus b. Remember that a bracket inside the bracket is always confusing, so I would encourage you to write it first like this, although it's not something that you should be doing here, but just to understand what is happening here, remember that whenever you have two transformations in x, one is a stretch and the other is a translation, the translation always happens first and then it is followed by a stretch if you're stating it like that. Okay, for the question here, it's not difficult to answer this question. The first thing that I see is there is a horizontal stretch involved, and this seems to have stretched more than a sine function does. This distance is, I think it's pi. Let's just cancel that out. Okay, this seems like a distance of 2 pi. Okay, typically a sine curve completes a complete cycle in 2 pi. So I know that this graph sort of has stretched by a factor of half, I think. Okay, since the distance has doubled, I'm going to say that there's a stretch factor of half involved. Okay, so it's stretch factor half. Okay, the distance has doubled. Remember that. So it becomes sine of half x plus b. Now, in order to find b, what I generally encourage you to do is I okay, so to find the value of b, the easy way of finding for the value of b would be to use this point. I think that's an easy value of 0 here, and that would help you solve the question quickly. So I can say that y is 0, a is half, x is 0, 0 plus b, and when I say sine inverse of zero point 0.5, I get sine of half into b. Okay, not sine of half, it's just sine, half of b, half of b. Sine inverse of half gives me pi over 6 of b, and b is therefore 2 pi over 6. Okay, there could be other ways to solve the question as well. You could look at transformations and then come up with the final answer as well. Moving on to the next question, this says another curve with equation y equals to f of x has a single stationary point at the point p comma q where p and q are constants. The curve is transformed to a curve with equation this. Remember that it's difficult to figure out x transformations when they are written in multiple brackets like that. I can work with one bracket um, only, so I'm going to keep that. Now the rule for x transformations is that if you have two transformations, one is a stretch and one is a translation, the translation always happens first, followed by stretch factor 4 in this case. Okay, so what does it say? It says for the transform curve, find the coordinates of the stationary point giving your answer in P and Q. So the x coordinate was P. It would first get subtracted by 2, and you would say that this becomes P minus 2, and then you would stretch it. You would say then the following transformation would be 4P minus 2. Remember that this rule is the opposite for Y transformations. Y transformations typically happen as a stretch first and then a translation, given that no the brackets are involved. With X, that is the rule. Then for the Y coordinate is getting multiplied by minus 3. There's a reflection and there's a stretch involved. It doesn't matter which one you do first. So the Y coordinate will become minus 3Q. So your turning point will be 4p minus 2 comma minus 3q. Okay. Okay. Moving on to the next question, it says the curve has equation y equals to 2x power half minus 1. Find the equation of the normal to the curve at this. So I first calculate dy by dx equals to half 2x power half minus 1 minus 0. Okay, so that gives me x power minus half. I use the point x equals to 4. And I get 4 power minus half, that's 2, that's 1 upon 2. Okay, and that's gradient of tangent half, gradient of normal is minus 2, so y minus y1 mx minus x. Okay, that is this question. Let's quickly verify that is the correct answer. Oh, that's 8, so that's 11. Okay, moving on, a point is moving along the curve y equals to this in such a way that the rate of increase of x coordinate is 3. Find the rate of increase of the y coordinate. So I'm going to construct my chain rule. I'm going to say that my differential can be broken down into its component such that dy over dx equals to dy over dt divided by dx over dt. So dy over dx is something that I've already calculated. So x power minus half dy over dt is what I want to find, and this is 3. What value of x am I using at a? What is the point a? Is point 4. So I'm going to say that 4 power minus half equals to dy over dt divided by 3. So that gives me 3 over 2 as dy over dt. Then it says that A, the point, moving point suddenly changes direction and speed and moves down the normal in such a way that the rate of decrease of the y coordinate is constant at 5. Now it's moving along the normal. Okay. Now remember that I am now moving along the normal. So my dy by dx should now be the gradient of the normal. Okay. So dy by dx is now the gradient of the normal, which is minus 2. Okay. As the point moves down the normal, find the rate of change of its x coordinate. So I'm going to say that again, I have dy by dt, dx by dt. So my dy by dx is now fixed at minus 2. My dy by dt here is 5 and dx by dt is unknown. So dx by dt is then decrease of y coordinate. So this is also a decrease, minus 5 over minus 2, which is 5 over 2. Okay. Moving on to question number 10, looks like a complicated one. It says the diagram shows points A, B, and C lying on a circle with center O and radius this. Angle AOB is equals to 2.8 radians. The shaded region is bounded by two arcs. The upper arc is a part of the circle with center O and radius R. The lower arc is part of a circle with center C and radius R. State this angle of size ACO in radians. ACO. This one. Okay. Now remember that this is a circle property that an angle formed at the center is twice that formed at the circumference. So this entire angle would be 1.4 and then ACO should be half of 1.4, 0.7. Okay, I hope that's the correct answer. Yes, that is indeed the correct answer. Let's just find capital R in terms of R. The lower arc is part of a circle with center C and radius R. So this is the capital R that I have. Okay, that's the radius of this sector. Okay, I want to find what? I want to find capital R in terms of small r. So let's divide this. Okay, I am going to say that this is half r and this is small r. So cos of 0.7 equals to half of capital R over small r. Okay, my calculator should be in radians. Yes, it is in radians, cos of 0.7. That gives me 0.764 r equals to half r. And then multiplied by 2, that gives me 1.5297. That gives me 1.53 r. So capital R equals to 1.53 times small r. And the area of the shaded region in terms of small r. Okay, so the area of the shaded region is going to be a little bit complicated since multiple things are involved. First, I'm going to focus on this sector of the other circle. I'm going to say that area of large sector is half capital R squared, no, small r squared times theta, which is 2.8. Okay, so 1.4 r squared. Now, if I can somehow come up with this area, okay, how do I find out this area? I have to subtract two triangles out of uh, a sector. I think that should be it. So area of shape, let's call that shape, is area of small sector minus area of two triangles. So area of small sector is, this angle should be 1.4. So I'm going to say that this is half r squared, capital R squared, 1.4, half r squared theta. And let's talk about the area of two triangles. So the area of the two triangles can be found by keeping this as an equal on both sides. So that's going to be 2 pi minus 2.8 divided by 2. So that's basically pi minus 1.4. So I'm going to say half a b sine of pi minus 1.4. Okay, I think that should work. There are various ways to do this question. Not necessarily I'm doing one way of doing it, and there are two triangles, so just like 2. Okay, so 2 times half. Okay, so that gives me this. I am going to replace capital R with 1.2, 1.53 only. R, don't forget R. What's sine of pi minus 1.4? Okay, 0.985. So 1.53 times 1.4 divided by 2. 1.0, oh no, 1.53 squared first, giving me 1.6386 r squared, 0.985 r squared, 1.6386 minus 0.985 gives me 0.6536 r squared. Subtracted from 1.4 r squared from top. 1.4 r squared was this, area of the large sector. See if I get the correct answer. 0.746. Okay, the marking scheme says 747 to 748. I will check why I'm getting a difference, because I think they've used more exact numbers than I did. 1.638. No, I've used more precise numbers. So I think my answer is fine. I should get enough marks. Okay, moving on to question 11. It says the diagram shows part of the curve this intersects with this, and R is the stationary point on the curve. Verify that the x coordinate of R is 3 over 2 and find the y coordinate of R. Okay, okay. So R is the stationary point on the curve. So the first question is about differentiation. So dy by dx, let's first move it. X plus 2 times 2x minus 1 power minus 2 plus 2 times 2x minus 1 power minus 2. Okay, first I have to differentiate. Let's differentiate this. Dy by dx equals to 1 minus 4 2x minus 1 power minus 3 into 2. Dy by dx is then 1 minus 8 2x minus 1 power minus 3. And R is the stationary point on the curve. Okay, verify that the x coordinate of R is 3 over 2. So equating this to 0, moving this to one side and taking power in the negative. So 8 equals to 2x minus 1 cubed. Taking a cube root, so I get 2, 2x minus 1, 2x equals to 3, x equals to 3 over 2. Find the y coordinate of R. So y coordinate of R is simple, 1.5 plus 2 times 2 into 1.5 minus 1 squared. Y equals to 2. So 1.5 comma 2. Then find the exact value of the shaded region. The shaded region is trapped between a line and a curve. I would want to find out what this line is basically first, so that I can find out whatever area of trapezium of the line, if you want to use the line. Okay, so this point is 1, and when I insert 1 here, I get 3. This point is 2. So let's see what I get. 2 plus 2 times 4 minus 1 squared. So it's 20 over 9. That's a difficult number. Okay, so okay. So first I find out the equation of the line, or let's do the area of trapezium. Area of trapezium, I think that's going to be easier to do rather than constructing the equation of the line minus the integral of the curve from 1 to 2. Integral of the curve from 1 to 2. Okay, what's the curve? X plus 2 over 2x minus 1 whole square. So 2x minus 1 power minus 2. What's the area of the trapezium? It's half into height. So this is going to be my height. This see it's this distance, so 2 minus 1. Okay, the height is 2 minus 1, and the parallel sides are different. One is 3 and the other is 20 over 9. So you add 3 plus 20 over 9. Okay, minus integral from 1 to 2 of this. So I'm going to integrate x square over 2. Let's make that a square bracket. Plus 2 times 2x minus 1 power minus 1 divided by minus 1 into 2. Okay, first let me integrate this to 2 square over 2 minus 2 times 2 minus 1 power minus 1, upper limit minus lower limit. Okay, it's a long calculation. Let's do this step by step. This gives me 2. This gives me 1/3. Then that gives me half and 1. Okay, what's the area of the trapezium? It's 3 plus 20 over 9 into half, 47 over 18. Okay, and inside the bracket I have 47 over 18 minus 2 minus 1/3 minus half plus 1, 18 over 6. I'm getting 4 over 9, and if that's the correct answer, sounds like a reasonable answer. Let's just check. Yes, the answer is correct. And that brings us to the end of the exam. I will see you with another exam. Sorry, there were some mistakes here and there, and the paper right now is solved and it's correctly solved. Thank you for watching.